Alright, so this is problem number 81, and I'm going to work letters C and D. In letter C, it says if 28.5 milliliters of silver nitrate solution are needed to precipitate the chloride ions in a 785 milligram sample of KCl, what is the molarity of the AgNO3 solution? So step number one is the same as the stoichiometry steps that we've used all along, and that's to write the balanced chemical equation. So our balanced chemical equation is AgNO3 plus the KCl, arrow, and then the silver will swap with the potassium, so we'll end up with potassium together with the nitrate, and then we'll end up with the silver together with the chloride. And handy, they're all plus one, minus one, so it's a balanced chemical reaction, so step number one is done. Step number two, when in doubt, convert to moles. So now you need to be good at looking at the problem and decide what information do they give you that can help you convert to moles. They give you a volume of AgNO3, but remember, if you're going to use a volume, you're going to have to know the molarity to be able to find the moles, and they don't tell us the molarity. And then it says that there's a 785 milligram sample of KCl, and I can convert from milligrams to grams. And then once I get into grams, then I could use my periodic table here to go from grams to moles. So that's what I'm going to use to convert to moles with the information that they give me. So 785 milligrams is 3 to the left, 1, 2, 3, so 0.0785, and that would be grams then of the KCl. Multiply sign, put a line, put grams of KCl in a position where it's going to cancel, put moles as your new set of units of KCl. And in 1 mole of KCl, we have to add that up on the periodic table. And potassium, of course, is 39. And then I have to add that to the chlorine, which is 35.5. And then I end up with 74.5 grams. So that's step number two. I'll have that converted to moles. Step number three is the mole to mole ratio. So now I'm going to take my moles of KCl, put it in a position where it's going to cancel, and then I'm going to compare it to the thing that I want to know, which is AgNO3 right here. So potassium chloride to AgNO3 is a 1-to-1 ratio from the balanced chemical equation. And then once I have the number of moles, then I have to convert to the asked for units. So if I stopped right now, I'd have moles of AgNO3. It doesn't ask for moles of AgNO3. It asks what is the molarity of the AgNO3 solution. And to find molarity, I take my moles, which I'll have right now, and divide it by my liters of solution, which they give me the milliliters right here. So let's run this through the calculator. 0.785 divided by 74.5, enter, times 1 divided by 1. So this is my number of moles of AgNO3, 0.0105369, a few more numbers. And this is my moles of AgNO3. And to find the molarity, I know that I have to take the moles and divide it by the number of liters. And the number of liters that I have are 25.8. So 25.8, 3 to the left, 1, 2, 3, so that would be 0.0258 liters. So let's take this number and divide it by 0.0258, hit enter, and we end up with 0.408 molar solution. Alright, letter D. In this one, I have 45.3 milliliters of a 0.108 molar HCl solution, and it's needed to neutralize KOH. How many grams of KOH must be present in the solution? So ultimately, my asked for units that I'm going to convert to are grams, and the start of the problem is going to be balancing the equation. So 45.3 milliliters of HCl, and then I'm going to neutralize it with KOH, and then swap the cations. I get H and OH together, and then I get K and Cl together over here on the right hand side. It's a 1-to-1-to-1-to-1 ratio, really nice ratio, easy one to work when I get to that part. Step number 2 then, look through the information that they give you and which thing could you convert to moles. So they give me a volume and they give me a molarity, and if I know a volume and a molarity, I can convert to moles. So my moles would be my volume of 0.3 to the left, 1, 2, 3, 0.453 liters times my molarity, which is 0.108 moles per liter. That's another way to write capital M or molarity. And then that gives me my moles of HCl. Then I'll take HCl moles and put it in a position where it's going to cancel for my mole to mole ratio. And I'll put the units that I desire on top, and I want to know KOH, because ultimately I want to know grams of KOH, but first I need to find moles of KOH in step 3 right here. So multiply these together, and it happens to be a 1-to-1 ratio because there's a 1 in front of the KOH and a 1 in front of the HCl. And then the last step is to convert to the asked for units, and the units they want to know is how many grams of KOH there are. So multiply sign, put a line, put moles of KOH in the position where it's going to cancel because I have moles of KOH right now, and then put grams of KOH as my new set of units. Add up KOH on the periodic table. K is 39, and then oxygen is 16, and then 1 for the hydrogen, and so I get 56 for my grams in a mole right there. Whoops, not 59, 56, sorry. All right, let's run the whole thing through on the calculator. I'm going to do it backwards because I have 56. 56 times 1 divided by 1, and then I'll multiply that by 0.108, enter, and then times 0.0453, enter, and I get 0.274 grams that are in the solution.